So, good afternoon, everyone. It's really an honor to be here. I was listening to the other two speakers, amazing stuff. I learned a lot of new things. What I'm going to do is take this discussion forward. Essentially, think of this as a continuum of what we just heard. Um, what I'm going to do is I'm going to talk about, uh, a philosophy about how our AI thinking has to evolve in order to imagine the products of the next generation, right? And I'm going to talk about the past stuff, but a little bit of the future and how Ola and other such things fit into all of this, right? Let me see if this works. Uh, all right, so just a very quick overview. I was already introduced, but the reason I'm putting this slide is to talk about my own journey from working in companies like Google and FICO and others, where we were building, single machine learning models, right? Information retrieval models or link prediction models or, single models. And then when I switched to, thirdly, Panola, I realized that there is something else going on in machine learning, which I wanted to share today, which is how do you transition from one kind of thinking in machine learning and AI to another kind of thinking in machine learning and AI. And really, this is about that transition. And when I say change in thinking, just think about the first time you learned about object-oriented programming, and suddenly your idea of how you think about programming changed, right? So your thinking evolved. Similarly, if you think about cloud computing, suddenly your idea of thinking evolved from programming on a single laptop to a cloud, right? So our thinking evolves, and as our thinking evolves, we imagine new products, right? And that's the key to the next evolution of AI also. And so let me start from the beginning, if you will. So if you think about all the technology that mankind has produced since the beginning of time, essentially what we have done is we have extended ourselves in so many ways, right? We just saw that if we cannot see beyond a certain light spectrum, we have created more sensors. Now our ability to see more has increased, right? If we cannot lift heavy things, we have created cranes to lift heavy things. If we cannot talk across the planet, we have created cell phones and cell towers and all that to extend ourselves in that way, right? So the idea is mankind is constantly extending our own faculties through technology, right? That's one way to look at technology in a very interesting, broad way. And if you think about it from different point of views, our tools have evolved, right? Back from the caveman days to the modern manufacturing cars. The first speaker talked about it. Our sensors have evolved, right? We looked at the vision sensors, but there are many such sensors. Just think of telescope, and telescopes have evolved from what Galileo built and what we have sent to the space and to Mars. So tools have evolved, sensors have evolved. Our computing has evolved, right? Starting from the good old days of ENIAC all the way to the cloud computing, and what's coming next, quantum computing and things like that, right? Computing has evolved, and if you think about data, data also has evolved, right? So today, it's all over the place in all kinds of domains. Every time a new domain comes up and a new set of sensors are put in, we are collecting lots of data. So this was data up to a certain point, and then when the internet came, there was a big change in the amount of data that started to get collected, right? With Google search and all these internet things. And now the next big change in data is coming with the Internet of Things. So data is also going through this staircase function, a very nonlinear growth, if you will. Yeah? So our data has evolved. And just to, we all are familiar with the numbers. I don't want to belabor that point, but essentially this is big data. And it's going to become 10 times more in the next 1 year because of the next wave of things, right? Now, if all we could do is to collect, transmit, store, and crunch on that data, take averages and all that, that's a big waste of this data. So the whole field of machine learning and AI was to make sure that this data is put to a much better use than just collecting and storing it, right? And if you look at the Industrial 4.0 revolution, companies that are successful today are not really search engines or Ola cabs or, they are all data companies. They start with being a search engine, they start with being a Netflix, they start with being a Facebook, but eventually they all become a data company. And that transition in thinking is very important. when we start to think about AI and machine learning, right? Now, another thing that has evolved is our ability to make decisions. And I'm going to talk about this because this is the real essence of what has happened because of machine learning and AI, right? So if you think about how we used to make decisions, earlier we would make decisions in a very batch way, right? Every year, did you pass the 10th exam? Did you pass the 11th exam? It's a batch decision as opposed to real time, right? Think about real time feedback to a student while he's solving a problem. On a step, he made a mistake, versus the homework goes to the teacher. 3 days later, it comes back. The teacher has forgotten, the student has forgotten, and there's no feedback really, right? So how do we make decisions from batch to real time? The second thing that has happened is we are now able to make decisions from broadcast to personalized. And we saw example of precision farming, where earlier farmers would put water, pesticide, everything on all the farms, but now we can do very personalized, right? So personalized education, personalized health, personalized farming, personalized even content consumption, right? So broadcast is you would watch what is on the TV. This is what happened in our parents' days. Today, you can watch whatever you want, whenever you want, right? So personalized and real time, right? And the third thing that has happened is, it's not visible, but it's tactical to strategic decision making, which means today you make a decision just based on what you know now, and you make a decision, but now decision making has become strategic. So how do you win a game of chess is not because you make a current move better, but you think about the future and make a strategic decision, right? How do you not do cross-sell now to this customer, but think of the lifetime value of the customer and make a sequence of decisions that will take him to the next stage, right? So these three dimensions is what AI and machine learning has been able to do, that we have gone from batch to real time, we have gone from broadcast to personalized, and we have gone from tactical to strategic decision making in this whole world, right? Now, let's talk about intelligent machines. There's a lot of terminology that is thrown at us all the time, right? Data science and machine learning and AI, and it's all kind of confusing at some point. What are these terminologies? So I'll just give you my little perspective before we move on to the AI part of it, right? So if I think about business intelligence in my mind is just reporting what has already happened in the past, right? So that's your business intelligence. You can draw all kinds of pictures and do all the analytics on it, and that is business intelligence. It's kind of like looking at your old photographs and saying, this is how I was, this is how I was, right? But that's not enough, right? That's not how we live in. We live in a world where we want to know what's going to happen next, right? So business intelligence is about the past, and then can I not just analyze the past but predict the future is where the next wave came, and this is what machine learning is doing. So it's able to predict this customer is about to churn, this Apple is about to go bad, what have you, right? So it's able to predict what is going to happen. Now, is prediction enough, right? So if the sensor sees that this Apple is about to go bad or there's a bad product on the tray, that prediction has to be backed by an action, right? And the idea of data science in my mind is when you throw a layer of the right actions, given the right predictions, together makes data science, right? Data science is a practical approach of how do you put prediction into action, if you will. So this is about creating the next future, the right future. So if you have predicted that a customer is about to churn, you take the appropriate action to make him not churn, right? So that is when it becomes data science. And the last thing is AI, which is more of not just taking one decision in the current state, but thinking of all possible decisions that will happen in the future, right? That's how we plan our traffic, for example, right? So you say, if I take left now, what will happen? There I'll get choked, so I should take right now, right? So the idea of I'm exploring all possible futures before I take my current action. And that is where AI kind of comes in, right? The good old-fashioned definition of AI. And this is how the evolution of these intelligent machines has happened in the past, right? So now let's talk about the products that were built on these kind of thinking, right? And if you look at the great products of the past decade, it's not a HD TV or something like that. TVs have been existing for a long time, right? The great products that evolved in the past decade were something around these kind of products, right? And what is common among these kind of products? Obviously, there's a lot of infrastructure, there's a lot of planet scale, there's a lot of cloud computing and engineering. But this, from a machine learning point of view, all of these products have done one thing well. They have taken one machine learning idea. If you think about Netflix, or Amazon and things like that, they've taken a recommendation engine idea and take it all the way, right? If you look at Google and YouTube, they have taken search idea and taken it all the way, right? So these products were built on one or two or few machine learning ideas, built on the cloud, scaled for the planet, delivered in a beautiful front end, right? That's the nature of what we call the product of product 2.0, which is they have a beautiful interface, they scale at the planet scale, and the last thing is they're intelligent like hell, right? Now, it's sometimes very scary that how did, Google know what I'm about to search by just typing 3 letters? Or how does YouTube know what to recommend next? And how did Facebook find my, schoolmate from the network of connections, right? So it's all intelligent products. And that's why machine learning and AI are not something special and esoteric and futuristic. They're all part of these products. And if these products are just beautiful and, scale, but they are not intelligent, we won't use them, right? So if Ola Cabs actually, allocates you a car that is 5 hours away, you're not going to find it useful. It may scale, it may have a nice UI, but it has to do something intelligent behind the scenes. So these are what I call product of the last decade. Yeah. Now let's think about what the products of the next decade might look like. And so let's look at the state of AI, if you will. So today, AI is at the stage of a 4-year-old. If you think about, the age of a person, where AI is today, I'm thinking it's kind of at a 4-year-old. And what can a 4-year-old do? It can do all the basic functions right? It can recognize objects, it can understand language, it can speak, it can run, it can, make games and play games, right? So AI is at that level where a 4-year-old kind of level where it is able to do a lot of things very interestingly. But what AI is not able to do yet is where we need to think about, right? What is the products of the next this thing? So today we are able to convert lots of data into very, very beautiful insights. We are able to convert our old rule-based systems into model-based systems. We don't have to have an expert sitting there writing out all the rules and that says if this happens, do this, if this happens, do this. Today we can learn these things and we can find a lot many rules, very, very fine-grained rules, right? So rules have become models. Listening has become hearing, right? So today your, Alexa devices are not just listening, they're able to understand what you're saying, right? And a phone will really become smartphone if it is able to understand what you're saying in it. And if you're planning a movie with your friend, imagine if it understands what you're saying, it connects to the agent in the other guy's phone, and the agents start talking to each other and looking at your calendars, looking at your wallets, looking at the past movies you liked, and actually figure out the right movie for you, which, and also book the Ola cab on the way, then the whole thing will kind of become a smartphone, right? So ultimately, I want to give you a picture of that is like a product of the next generation. Yeah. So we have all the building blocks. Now we just have to move to the next level, right? How about looking becomes seeing? So we saw a lot of seeing, right? Seeing the unseen and all that. And today you can take a picture, but if the camera tells you, this is your mom's picture and whatever, or it tells you that the picture is not correct, you need to take it again, whatever, right? So it can understand the images and not just store it, compress it, beautify it like Instagram and all that, but can do a lot more, right? And that is possible now. I want you to imagine this. When internet was, first crawled by Google, it was just a bunch of keywords, not even keywords, fingerprints, right? Then Google realized it's not fingerprints, it's keywords. So I need to do something about keywords. Then it started to understand the web and said it's not a collection of documents, it's a repository of knowledge. And Google migrated from the view of internet is a collection of the documents to it's a repository of knowledge. And Google transitioned, again, a change in thinking from the indexing and searching to a knowledge graph way of thinking, right? That transition was very important. Now imagine if Google can understand all the YouTube videos, right? Today, we just store them and we call them and we search them. But imagine if I ask you, hey, give me all the shots that Sachin Tendulkar made, which is a square cut, and that's all I want to see, right? I'm interested in learning that. So today we cannot do that because you have to watch the whole video to figure out where that shot is, right? But tomorrow's, Alexas will be able to answer that question and show you those snippets where this happened, right? Because it understands the videos that it is seeing. So this ability of looking to seeing is very profound. Reading to understanding, we talked about it, right? Reading is just looking at the words, parsing the sentences, doing, and then understanding NLP, what are you saying, what is the knowledge, what do you mean, is it a joke, are you making a sarcastic comment? You see how the complexity of that cognitive task is, right? So reading to understanding and moves to strategies. So, yesterday we were building, your BTech projects, you would say, okay, I want to build a chess system, and in this board position, these are the 5 moves I can play, but which is the best move is a strategy. And can I not encode the strategy, but learn the strategy by making 2, AI systems play against each other and improving over time. And as a result, we have Deep Blue and we have AlphaGo and all these beautiful systems, right? So computers are able to learn strategies. So the state of the art is this, right? So we are at a 4-year-old. We have all the building blocks, right? And what can we do when we combine them? And the first speaker talked about, the network of intelligence, right? How do we connect all of these together is kind of the key. So if I think about the products of the next decade, they're not just going to be a better search engine or a better social network. Yeah? They're going to be something very, very different, right? And they're going to be things like, and we have already started to see the glimpses of it, they're going to be things like connected cars. Imagine connected cars, right? So your car talks to the car of the next guy, so you don't have to talk and, do your negotiations in driving. Imagine the cars are talking to cars, the cars are talking to signals, the cars are talking to the cloud, the cars are talking to the maintenance and OEMs and all that, right? And how the cars are now agents, alive agents that are sensing and learning and all that, right? Connected homes, your home are connected to all kinds of things. Imagine the possibilities, e-governance, smart cities, right? So I like to think of a product 3.0, a smart city is a product 3.0. It's not just a city. The way the idea of the product has to be thought of is, what all can a city do? What are the features? How is it going to work in the new AI connected environment, right? So these are going to be the products of the next decade, and we are getting ready to build them now, right? So the next big companies are building these products, right? We have done deep learning. We understand how to identify weeds from plants. Now we are ready to build products around it, right? We have got that sensor in place. Now we are ready to build products around it, right? So how do we take this whole thing to the next level is the key, yeah? So now let me add one more I. So obviously interface, infrastructure, intelligence, but the idea of integrating all these things together. So if you see how Alexa and Google Home work, they basically are not just about speech. They're not just about the knowledge graph. They're not just about, the natural language processing. They're not just about question answering. They're not just about looking up your calendar. They're all of it together, right? So it's kind of like all of it together is what the new imagination of the products are going to be. And let me show you some examples of that and tell you why, products like Ola are very different from products like just Google search. Yeah? And that evolution you will start to see. So if you think about e-commerce products, right, it's not just 1 or 2 machine learning algorithms doing their little thing, right? It's not just about one recommendation running here and one coupon system running there and one, inventory system running there. They're all connected to each other. They're talking to each other, right? These are AI systems that are talking to each other to make, Flipkarts and Amazons of the world more and more efficient, right? If I look at, the work I was trying to do in my startup, I called it the teaching machines. So imagine if, today what happens, we study in a very old, 200-year-old way of learning, right? You have 40 students, you have one teacher, the course has to be finished, everybody has to learn the same thing at the same pace, and there's no personalization, right? So that is the broadcast model, right, we talked about. And now, can we do something personalized instead of broadcast, right? So again, what would that mean? So to build a teaching machine, it would have to have all these capabilities, right? It should be able to recognize a formula or a handwriting or an image or a language that a student is saying. It should be able to understand the student, each student differently, and say, what does he know? What does he know? What can he apply? What can he apply? What kind of mistakes this guy is doing and that person is doing? And what is his behavior of, and how does he get tired and things like that, right? So the whole idea of understanding students and then using that to personalize the curriculum. What is it that you're going to study next? Personalizing the content. Who are you going to study this from? Imagine you have 200 videos. If you just search for quadratic equations on YouTube, there are 100,000 videos on people teaching how to do quadratic equations. Now, how does a student know which one is best for him, right? So content personalization. I have a different style of learning than the other guy. So I should be able to learn from a different teacher than the other person, right? And how does the AI system do that? What are the best problems that I should be solving and the other person should be solving, right? And if you give the same homework to all the kids, you know what happens, right? And so on. And obviously, it should be able to have a communication with the student. Can the student say this and, the system recognizes that you didn't get the thing or whatever, right? Can you have a conversation? Can you recognize gestures and emotions, right? So we need all these technologies working together as a single whole to come up with the product of this kind, which is a product 3.0 example, right? And that's where I think the new innovations will come. So let me give you an example of some of the deeper properties of such a product, right? Why is it a little more complex than a simple Google search, right? All right, so a lot of people ask me, why did you go from Google to Ola? And, this is kind of the answer to that, yeah? Okay. So if you think about, what happens in Google is, if you search for a document, your document comes to your, browser, but it is also available to everybody else, right? It doesn't disappear from the web while you are looking at it, right? But what happens in Ola? Once you book a cab, it is gone, right? And now it will appear somewhere else and, it's gone for the time of the ride. So it's not an infinite resource system. Google is an infinite resource system. You make copies, but I wish we could make copies of cabs as fast as Google can copy the pages, right? If you compare it with Amazon, right? If you think about when you buy a product from Amazon, the product cannot say, no, I don't want to go to this guy, right? Because you talked about the driver denied duty. So he cannot say, because the last time, this guy used a Mixie, he really abused it, and I'm a Mixie, I don't want to go to this guy, right? And the Mixie gave a report to the other Mixies that, hey, this is bad, right? And today this happens. You rate the driver, and the driver rates you. We don't use that yet, but imagine if, there are rude customers and there are sensitive drivers, you don't want to match them together, right? Think of a very simple thing like that. So two-sided marketplaces, this is what we call a two-sided marketplace, right? When you connect A to B and you are just sitting in the middle and doing the connection and collecting your 20%, right? So in a two-sided marketplace, things are far more complex than a one-sided marketplace. Another example, if you go to a doctor through Practo or something, once the doctor is done with you, he's still there, right? He doesn't go to some other place and appear somewhere else, but Ola cabs can appear anywhere else in the system, right? So it makes fleet management a far more complex problem than, all these problems put together, right? So think of it as a multi-agent, drivers are agents, customers are agents. It's a resource constraint. You don't have infinite cabs, right? It's a multi-objective, and I'll talk about multi-objective. This is a new property of the products 3.0. It is multi-lever. That means there are multiple types of actions you can do. Google search is only one action, right? LinkedIn, if you're doing a search, is one action. If you are predicting a new link, it's one action. But here you have many, many actions and levers, and I'll talk about that. And it's a two-sided marketplace optimization, right? So, that kind of summarizes why I moved from Google to Ola. It's a much harder problem to solve, yeah? All right. And this is a glimpse of an example of a product 3.0, yeah? We didn't build Ola before we did Google, right? We first built Google, then we are building these Uber and Ola products. So I want you to think, what are the key properties of such a product, right? Don't think of Ola alone, but think of all such future products. So these products are not going to be just a collection of 30 different machine learning models, right? Working in silos, doing their own thing, uh, and solving for their own metrics. It's not going to be that. It's going to be a single optimization problem, right? So think of all the things you could do right or wrong at Ola or at Uber, which is if you allocate the wrong customer to the wrong driver, if you do some price something higher than something else, if you do one little thing wrong, the whole system goes out of balance because the overall system has to be efficient, right? So that is the new thing that I learned when I moved from my previous jobs to this one, that, oh my God, there's a new thinking that we need to bring to this kind of a problem space. Yeah. So let me give you a very simple example of, it's a web of signals and actions and models and metrics. So these are 4 terminologies we'll think about. So think of signals, which is how much is the demand, how much is the inventory. You can use this in retail, you can think of it in Ola. So imagine a location and a time, how much is the demand, how many cabs are there. If you make an offer based on that, so you say, you know what, I have more supply than demand, let me make an offer, reduce the price of cabs or reduce the price of milk because it is going to go waste, right? Whatever offer you make. What does that offer do? It kind of, now the offer again changes the demand, right? So you made an offer and suddenly the demand goes up, right? So you are affecting demand in some way. Now demand and inventory, which is the new demand and inventory, affects the way you price it, right? Price is a combination of supply and demand. And obviously you need to take the cost into account and see how much profit or loss you're making. So you're going to think of profitability. And then based on the pricing, you will see whether a customer will actually take the cab or not, right? If you price it too high, he will not take. If you price it too low, everybody will take. And again, there's a imbalance that will happen, right? So conversion. And conversion can lead to a better cross-sell, right? So if you're driving a smaller car, can I move you to a higher car? Can I acquire a new customer because I have priced something lower? Or can I make you a more loyal customer? Or can I price a little higher and make more money on you, right? So it all depends on what the objectives are. And then conversion will affect your sales. And again, sale is a function of demand and conversion, right? And then sales will again go back and affect your inventory, right? So you see, there is no starting point and ending point. There's no like input and output. It's kind of like a web of things. And if you choose one thing, the other things will affect each other. And this is just on the pricing model. If you think about other things, they are far more complex, right? So we start to get that idea of what we need to now start thinking about a new way of evolving our AI thinking in the first place. So if you think about how the old banks and all the old companies, even Googles and Amazons have worked, what they've done, they have over a period of 10, 15 years, they have built a collection of models, right? So that is how they look like today, which means I have a model to do search, I have a model to do ads, I have a model to do YouTube search, and these are all different models. They don't talk to each other, they don't affect each other, and it's a library or collection of models, right? So if a bank starts with and says, I want a credit risk model, then I give a credit card to this guy or not. Then I need a credit card fraud model because now I've given a credit card, there's fraud going on. Then I need this model and churn model and this model. So they all built these models, which is a collection of models over a period of time. As you recognize a pain point, you create a new model, right? So that's how they look like today. And this thinking is not going to work. Yeah. What we need today is to think of a system of model, which is how these models are kind of affecting each other, right? And I showed the example of that before, that your pricing model affects your conversion model, that affects your sales and inventory and this metric and that metric. So you need to start to think holistically about it like an architect, right? Not one box at a time, but like an architect, and the relationship between these boxes is going to make the whole thing work. That's how Alexa works. That's how connected cars work. That's how connected homes will work, right? They're going to put all of these together to make the whole thing work, right? So let me go through, 2 parts now, right? So there's a whole zoo of algorithms that you're going to study in this course. And I call it a zoo of algorithm because by the time you're done with it, you'll wonder, oh my God, why are there so many tools, right? To do this and to do that and all this stuff. So there are reasons for it, right? And you will see how to put all these things together in a single framework. So, just to very quickly go through the zoo of algorithms that we'll study, right? So one is what I call summarization algorithm. So you're going to have, millions and millions of data points, and you don't want to think of memorizing all the data points. Can you summarize them? In this case, we have taken 50 million customers of a retailer and clustered them into 50 clusters by what they buy and all that. Now you can do targeted advertising or marketing on each cluster instead of sending the same coupon to everybody, right? So there's one class of algorithms called summarization algorithms. The next class of algorithms is what I call semantic algorithms. So these are algorithms that are able to understand the data, right? So here what we did, we put a whole bunch of restaurant reviews, Yelp data, and asked the system to learn the meaning of the word, all the words that it, do you understand the meaning of the words? And we asked the system, now tell me that you've read all the Yelp reviews, tell me what is the meaning of the word ambience. And ambience is a non-trivial word, right? And we saw what came out, and it came up with these words as similar words. And it said, ambience, the wrong spelling of ambience, and these are all people writing words. So for the machine, everything is a spelling mistake. Yeah? Think about it, right? It came up with things like relaxed atmosphere, laid back atmosphere, music playing in background. Now just imagine the capability. This machine has never been to a restaurant. It has never experienced ambience. All it has done is read a whole bunch of people writing about this stuff, and it figured out the word ambience co-occurs with these words, and the word music played in background co-occurs with the same set of words. So ambience must be similar to this guy, right? That's how we learn how to understand language. That's how kids learn meanings of words. And machines are able to do that, not just meanings of words, but also meanings of sentences, right? So if I say this is a sentence, tell me similar sentences people have written. And again, look at the dirtiness of the data, right? And this is one of the first things you will hit when you hit a real world thing, that there's no such thing as normal distribution, there's no such thing as clean data, and all that good stuff will hit you. And then how does machine kind of overcomes all of that? Yeah. So this is what I call semantic algorithms. Another class of algorithms is what we call extraction algorithms. What they do, they don't just understand the text or images, they extract knowledge out of it. And this is what our brain does. When I read a piece of text, I don't remember the text anymore. What do I remember? I remember what things were there and what were the connections among those things, right? So this is what a conversion of text to knowledge graph is. And there are a lot of algorithms, which, named entity recognition, relationship mining, which will help us extract knowledge out of this. And this is what Google did when it transitioned from web as a collection of documents to web as a repository of knowledge, right? So now you have Google Graph, and a lot of your questions are answered by Google Graph and not by the search engine, right? Another class of algorithms, again, interpretation algorithm. What am I seeing? Understanding, interpretation, right? So here, detecting objects, beautiful examples that were given earlier, right? Think of sentiment analysis as a interpretation algorithm. How do you interpret a tweet or a little thing, right? You have to extract what is the entity you are talking about, which aspect of this entity you are talking about, and are you positive or negative about that aspect, right? That's how, when I read a review like, the food was good, but I think it was a little pricey. So I'm talking about two different aspects and saying positive about one and negative about one. That's a level of detail to which sentiment analysis has to work. Yeah. We all know about prediction algorithms. We do this all the time. Is this a fraudulent transaction? Is this customer about to churn? We have a whole bunch of recommendation algorithms, right? And to me, the most important recommendation algorithm that the world has to build is the following, right? So given that one student is good at these concepts and not good at these concepts, another student is good at some other concepts and not good at some other concepts, what should I teach this guy differently than this guy, right? I mean, that's a real recommendation engine we really need badly today, right? We don't need more, product recommendation engines and coupons and flight recommendation engine. If somebody can build this, then I think we'll completely change the way we think about education. Yeah. All right. And then there's another class of algorithms that we call thinking algorithm, which is about strategic as opposed to tactical, right? So machine learning is about one input to one output, prediction. But if you think about a sequence of actions leading to something profound at the end, is a different kind of thing, which is more of thinking algorithms, right? And if you think about, maps and playing games and having a chat or a conversation, to me, is actually a sequence of actions. What will you say, then what will he say, then what will you say? And it's a sequence of actions which could lead to either a meaningful, coherent, efficient conversation, or it could lead to, small talk. And that's the thing about strategic thinking and thinking of conversations as a thinking algorithm. Yeah? And then obviously problem solving, right? How many ways can you solve a problem? Which is the best way to do it? And one of my dreams is to build an AI machine that can crack an IIT exam, right? And get it's like it goes in, 3 seconds later it comes out and it gets a rank of 100% score and we are done, right? And that will completely change the way that's the kind of moonshot projects we have to think about to take the state of the art to that kind of level, right? That's what IBM did with IBM Watson to understand language, to solve, crack the Jeopardy or to play chess. Can we crack IIT using thinking algorithms and language understanding and understanding of the knowledge of physics and chemistry and math? How do we build a problem-solving system? We are not there yet. So that's what I mean by a 4-year-old AI needs to go to a 15-year-old AI. And these are kind of the challenges that we need to think about. Yeah. All right. So just to sort of summarize. So we have a zoo of algorithms. Is there a way to think about all of them and say, yeah, we need all of them? Right? It's not that you need just a few. Why do you need all of them? I want you to think about that, right? So there is a unifying architecture of AI, which is us. We are a unifying architecture of AI, and let me tell you what I mean, right? So how do we operate in this world? We get a stimuli, right? We observe something and we analyze that. So I want you to imagine crossing the road, right? So you're trying to cross the road. You look at the car, your visual system. You analyze whether the car is speeding up or slowing down. Is it far enough? Things like that. And your knowledge graph, the knowledge in you gives you the common sense knowledge. You have a goal. You have two goals here. One is to cross the road in your lifetime, right? And to not die, right? Because crossing the road in India is one of those challenges, right? So you have a goal. And then you start thinking, should I move? Should I stop? Should I slow? Should I do this like this and walk? All these things, right? So we do this thinking. And then, obviously, we execute on that thinking, right? So we synthesize what we have thought about. And then, based on the result, we learn, right? So we learn that, I was about to die, the car almost hit me. Or it was easy for both of us to, go our way, right? So either I could be making errors in my judgment of how fast the car is coming, which is the errors of analysis, or I could be making an error in what action should I take given this is what the state of the world is, right? So I need to optimize both these in order to come up with the overall thing. So this is the architecture of AI, which is applicable to every problem that you can think of. Yeah. So now let me give you a few examples. So we'll start with the metric because, one of the most beautiful statements I heard is if you don't know where you want to go, then any path will take you there, right? So I think metrics, what is it that you're trying to optimize is the starting point of all your machine learning problems, right? All right. So now if you think about the metrics itself, the product 3.0 will have not one metric. So Google search has one metric, right? Which is maximize the click rate on the first result, let's say. But if you think about farming, it has multiple metrics, right? Maximize the yield, minimize the cost. If you think about retail and selling coupons, you have multiple metrics. Should I cross-sell? Should I upsell? Should I do a lifetime value? Should I make him a loyal customer? Which is the best thing to do for this customer today, right? If I think about fraud, again, I want to minimize fraud. I want to maximize convenience, and I want to minimize the time to catch the fraud transaction and so on and so forth, right? So what I'm trying to say here is there is a collection of metrics that have to be simultaneously looked at together, right? So in the old way of thinking about AI, when we think about metrics, we only thought about how to improve a model, right? How to make a better model, machine learning model. So we'll take metrics as one of these and try to maximize that metric. So this is my model thinking that happened in the past. The new thinking is not about optimizing one metric independently of the other metric. How do we think about the joint metric, right? So think about pricing is not just trying to optimize the revenue and profitability, but also trying to make sure that the right cars are placed in the right places after I'm done with the current set of rides. So there are two different metrics, and I may have to lose a little bit on profitability to make sure my cars are in the right place in the next iteration, right? So you see, it's an interaction of metrics is the key property of product 3.0. Yeah? And these metrics will be trade-offs. So now I want you to imagine that these metrics are trying to say, can I go first? And the other metrics say, no, I need to go first. And let's negotiate which metric is best to optimize in this state, right? So that's how we need to think about metrics differently. Yeah. So let me give you two concrete examples from my two companies. So if you think about education, I want to give you these 4 keywords that will always help you in thinking about, putting together a system. So we talked about metrics. So any problem you're solving, we'll start with the business metric and list them down, right? So that is the metrics I want to maximize or minimize. Then what we'll do, we'll look at all the signals that I'm collecting. So this is the, all the sensors that I have. You saw how in farming they have so many sensors. So there are signals all over the place. In Ola, we have signals like, where you are, what was the last ride you did, did you, is it night, day, are you a male or a female, is this driver good or bad? So we have all these sensors and signals, right? So we'll have all these signals. Now here comes the key part to this, right? So there are so many signals, so many numbers coming at you, you don't remember all of them. What do? You build what we call a state of the system. And that is the key. It's kind of like saying, I observe the board position, and there are so many possible board positions, but is there a way to say what is the state of the system? Am I on the better side or losing side in the chessboard position, right? What is the state of the system is a summarization of all the signals in a way that is meaningful and semantic, right? So there's one class of algorithms that are going to convert signals into states. States are canonical representation of what you think the world is like given these sensors. Yeah? And then the second class of algorithms is doing nothing but taking the state and converting it to the right actions, right? What should I do with this student who is struggling with this concept because he did these problems wrong and these problems right and asked these kind of help. So that was the data. The state is a summarization of all of that and saying he is struggling with this concept. This is a summary of all the data. And then what action should I do? Should I teach this again or should I take him to the prerequisite is the action on it, right? So that's these 4 things, metrics, signals, actions, and states is the key to this whole thing, right? So let me tell you how we do this in Ola. The same thinking which we did in education, how do we do it in this, right? Again, think about signals again. What am I collecting? So I'm collecting all the things that the customer is doing on the customer app, the driver is doing on the driver app, any third-party data, what is the weather and all that. The internet, are there events going on in the city that will affect the traffic patterns, right? And other sensors like LiDARs and other sensors later that might come, right? So you have a whole plethora of signals of different types. And then what do we do with them? We build a whole bunch of what we call models around entities. So we try to understand customers, right? And say, is this customer sensitive to price? Is he sensitive to this? Is he sensitive to ETA in the morning or in the evening? How fine-grainedly you understand your customer is the fine-grainedly you'll be able to give them the right optimization. Again, driver models, right? What kind of driver behaviors people are showing. Some drivers just come at 12 o'clock and go back at 4, so they only work during the lean time, right? How do we make these drivers work in the evening and the mornings also, right? What kind of incentives will make them do that, right? Then demand models. Can I predict demand in different locations at different times, which is kind of the bread and butter of any such operations company, whether it is retail or taxi. We need to be able to predict demand, what factors it depends on. When the temperature goes up, or there is rain in the city, suddenly the demand goes up, right? We all have seen that. Morning time, the demand is more from the residential areas. Evening times, it's more from the office areas, right? Even, weekends, it's very different, right? So how do you do demand prediction, supply prediction, right? What is the probability that this driver is about to move to another location because he didn't get a ride in this location, right? When does he do that? Things like that. Location models, what kind of location is this? Is this a college? Is this a residential and all that? And event models, right? What is the effect of flight and train cancellation on traffic patterns? So you see, we are not even doing any taxi allocation yet. We're just trying to understand the state of the system, state of the customer, driver, location, all these things from the signals that we are collecting. So this is signal to state models. And then we go from state to action models, right? And this is where product 3.0 is, which is you are going to have many different levers at your disposition. Like in education, you can either show the student a video, or you can give him a small test, or you can ask him to, go drink some water. Depending on the state of the student, you can do different actions, right? So here are different actions here, which we can do. And then based on the action, the environment will tell me what is the effect of those actions on different metrics, right? Did the customer cancel? Did the driver cancel? Are my profits going up? Are my profits going down? Am I giving too many incentives? Am I giving too many offers? And I'm not able to keep up with them? All kinds of things, right? So anything you do in terms of state understanding or action prediction can throw your entire system off balance, right? And that's what the delicacy of this whole thing is. And once you get your metrics, you go back and learn and say, did I do my states better? Did I do my actions better, right? So the same diagram I showed, which is what we do as humans, stimuli to understanding to actions and all that, we do in Ola, we do in education. Yeah. So that's the general picture to keep in mind and say, okay, there's going to be a continuous feedback loop, right? Depending on which action I took in which state, I am either going to lose the game of chess or win the game of chess, and therefore can I learn from that, right? So state to action, there's a constant learning, and there's a constant, improving of the state models and the action model. So this, in my mind, is a very broad picture of how you can think about any new sort of an AI system, not a collection of models, right? And now, why did we talk about the zoo of algorithms? Because this is where the zoo of algorithms fit in. So there are all these algorithms which can be classified as signal to state algorithms, right? These are algorithms that help you understand what's going on, right? So, for example, summarizing, semantics, interpretation, all that is trying to understand signals to state. How do you represent the state? And then there are a whole bunch of algorithms that are used to take the state and say, what is the best action in this state? So reinforcement learning, prediction, simulation, reasoning, thinking machines, all that stuff is. And then from actions, you're going to take metrics and do multi-objective optimization. So, different kinds of machine learning algorithms plus optimization together makes up the whole system work. That's kind of the message. Yeah. All right. So let me just summarize. So where is AI heading? So obviously we have come a long way in learning algorithms, in understanding algorithms. We understand speech, we understand images, we understand videos. Almost, it's coming. The next thing you will see is understanding of videos. It's in the academic world, but it's transitioning to the products now. A lot of thinking kind of things. Autonomous vehicle is not such an easy thing. The car even has to plan how it will turn on the curb. And now imagine doing it in India, right? So that's another challenge altogether, right? So, all these companies have given up on India. They're saying, let's do it in US first, and then we'll come up to India, right? What about machines being creative, right? Can they create music? Can they write papers? And can they create a joke, right? Think about that. It would be a very awesome act of creativity if a machine creates a joke at some point. And finally, 200 years from now, machines might become conscious, which is, imagine your cell phone saying, hey, I don't want to give any more calls, I'm tired, right? It has a, sense of purpose now. Because imagine that's what we are doing. We are telling the phone, be my personal assistant, right? And what happens when you abuse your personal assistant too much? They go on leave and they quit the job, right? So imagine if phones could do that someday, right? So that's the idea of consciousness, and there's a big debate going on about what that means, right? But in all this evolution, we'll have to start transitioning from thinking about individual machine learning models and the next layer of it, which is how do we put them all together to create an ecosystem of AI, if you will. Yeah? So I'll stop there and take any questions if you have.
I have one question about this AI application. So, in one of the recent events in Hyderabad, there is this humanoid robot Sophia from Hong Kong. So, when asked a question, "Who is your favorite Indian star?" it instantly answered Shah Rukh Khan.
Huh.
So, I'm wondering, is that a scripted answer, or is it related to something like ambience you showed, where it picked from people's
Yes.
input?
Yeah. So I'm sure that is a scripted answer. So let me give you an example. When do we go from AI to scripted, right? So the idea is wherever things are subjective. So let's say on Ola Play, you say tomorrow, hey, play me the latest, Jagjit Singh song or whatever, right? Then what will it do? It will sort by a certain parameter, right? And say what is most people hearing and sort by that, right? In this case, so that is one level of personalization. If you ask the system, play me my favorite Jagjit Singh song, then the system should be able to do something more personalized. But if you ask it a very generic question, what is your favorite Jagjit Singh song, then it has to be kind of like given a personality and given a answer, because I don't know machines are yet able to appreciate music the way humans do, right? Or movies or acting and things like that. These are very, very cognitive tasks. So in order to make the whole thing feel complete, right, you have to give it something which is very intelligent, something which is kind of, hand-waving, and something which is hard-coded. Because otherwise it will work on only some things and not on the others. I'll give you a very nice example. So we got this Google Home in our home, and we started asking questions, what is the capital of India and things like that. And then suddenly my 3-year-old asked it, what is the name of my grandmother? And how would the machine know, right? But it could tell where do we live, right? And that was kind of scary, that a device from Google all the way from US comes in your home and it can tell you where you live, right? That's kind of scary. So yes, there is going to be a spectrum. And then when my daughter trained it and said, this is the name of my grandmother, the next time it was able to say that you told me that the name of your grandmother is so-and-so. And this is the you told me part is the lawyers coming in, right? Because, otherwise something else will happen. So you see how the machines know what they know what they don't know, and they can learn what they don't know, right? And I think, but answering factoid questions like that is not the real capability, right? The real capability could be, that, hey, I'm in the mood for a movie, tell me what I can watch now, right? And it should be able to connect to all of that and tell you which movie is best, or things like that, right? What should I eat today and stuff like that, right? So, and then there is more. What should I study? Which course should I take? I want to be a data scientist. Here is my resume. Can you imagine LinkedIn doing these kind of products next, right? They can plan your strategic journey of a career path by looking at your current state and telling you what action you should take to go to the next state. Again, state action thinking we can apply. So I think these products have solved the cool communication and interface problems and the basic factoid problems, but I think they need to go to the next level, become more personalized, and then, obviously they're learning all the time. So, but I think, it's a beginning, and we'll see very beautiful things coming out. Okay?
Sir, I have a question regarding Ola prediction.
Okay. Limited answer, yeah. Okay.
One day I'm traveling in car. In FM, they said there is a very traffic at some Nampally station. So that's why I'm able to know as a prediction. So Nampally is in the very traffic area. So today, one day in Saturday morning, I book a Ola cab. They given the cost 300 rupees. The same cab, when I book the cab, my destination, it's cost 400 rupees. So is there how you are predicting based on the traffic or based on the rain? Today, we don't know the rain will come. After I booked the cab, the rain got started somewhere. So which type of prediction you are going to take in care for this based on the rate, based on the feedback reviews? And I find one weird situation like the same distance in Sundays when the river, when I'm coming back the fare is different.
Yes.
The same distance, same time.
Yes.
So
Oh, time
how,
also.
which type of scenarios your prediction going on for
So
this?
we
scenario?
do have a time plus distance based pricing, right? And I think even Google Maps and Ola has our own version of predicting time. Currently, they are not doing the perfect thing, which is, so let's say you go from A to B to C to D. Now, if I know A to B how much time it will take now, and B to C how much time it will take now. Now is not what we need. We need how much time it will take from B to C when I reach B, right? This is the next evolution of what we call predictive, ETA prediction, if you will. And if we are able to do that better, then we'll be able to do pricing better, right? So because traffic patterns are very, highly prone to noise of all kinds, it's very hard to predict what will happen from B to C when I will reach there in the next 15 minutes, right? And therefore, pricing is currently based on what is the situation in all these places now. And you see, therefore, the discrepancy. Yeah? But yeah, and we play with different pricing algorithms also. So sometimes you see a higher price, lower price because of that also. Yeah. Pardon? I can't hear you. Sorry. No more Ola questions, huh? Like the other gentleman said, he's on his own, I'm on my own.
Not like that. My interest is the regression classification. Continue you are doing based on the when I'm journeying customer from A to B, B to C. So the continuously you're monitoring based on the time.
Yes,
So
yes.
are you in any particular station?
Yeah. So like Google updates the ETA, right? It changes the time of arrival based on the latest estimate of the future. It's the same thing, we do that. But accordingly, the prices are not updated right away. Eventually, the final price you see is the overall result of the whole thing.
Okay. Yeah. Thank you.
No more Ola questions, huh? Or maybe...
Hello, sir.
Yes.
Actually, not related to to Ola or Uber. We are using some infrastructure like Google Maps in the applications. What if Google Maps start using their infrastructures, like they will predict the cabs and all those things, and they will make a product, like they will use the, like you are saying that Google machine learning algorithms or others are silo, but what if they start making products and making use of their data and all those things?
Yeah, why not? Why not? I mean, that's the beauty of it, right? Every company has a right to venture into a new kind of thing, and once they realize that the power of their data, I mean, Google Maps data is one of the most amazing products in the world today, right? Both from scale, real-time personalization, all points of view, usefulness is one of the most beautiful products, and obviously so many use cases, right? And Swiggy uses it, Amazon uses it for delivery time, we use it for ETA prediction. So everybody is depending on them to do this, and once they realize, I could be doing Swiggy and Ola and delivery, why am I letting these people do? So what they've done, they have started to charge for it. So this is a very interesting thing I wanted to talk about, which is companies that are building fundamental infrastructure pieces are making a lot more money than companies that are just building products on top of it.
So, sir,
right?
one thing.
So if you are building a chatbot for your organization versus if somebody comes up with a whole chatbot framework that anybody can use, that company is far more valuable than just one, user of the chatbot in one domain, right? So this transition, you should observe this happening all over the place, that because Google has built these beautiful infrastructures over a long period of time, it is now able to monetize those in different areas, right?
Okay. So, how could we if we want to make something this like Google Maps of product in India, how long it will take for Indians to make the products?
I think we should start thinking about India-centric products now. Yeah, it's high time that we keep thinking about products like the products that were invented in the West. I think it's high time we start thinking about products we need in India. Right? Farmers need a lot of different products. Students need a lot of different products. And I'm not talking about, Chaitanya and Narayana coaching. I'm talking about real EdTech products, right? So, we need a lot of India-centric products. So don't worry about, they have already done everything, we have nothing else to do. There's a lot of innovation. We saw how agriculture is revolutionized in other places. How can we do this in an India context, right? Even autonomous vehicle, when Ola starts to think about autonomous vehicle, we're going to deal with cows on the road and autos and bullock carts. And we're going to not just be able to take their model and say, okay, it's going to work here, right? So we're going to have to do a lot of customization for India. If you think about like Khan Academy, for example, right? It was built in English language and all that, but when he has to come to India, he has to do it in like 25 other languages, right? So Indianization of a Western product is a huge area of open research and product development. Yeah,
It's like
and coming up with India-centric products.
India-centric. Okay.
Yeah.
Thank you.
I think the mic is somewhere else. Yeah. Okay, you are in queue now. Okay.
You are in queue.
Yeah. So the AI system and what you came out with, I think it's really incredible and impressive. My question is, as a startup, where do you start and what do you take as a first bite to chew, or how do you approach this? Quite a comprehensive system if you want to build now. Of course, the big companies have let's say the user base, the data. All of these are challenges for a startup. So how do you approach as a startup, and where do you start?
Yes, very, very good question. So, a lot of startups, I kind of work with a lot of startups, and, one of the big mistakes they do in the beginning is they think that they are building a product that they are building, right? Paytm is just a payment gateway thing. Ola is just a cab service, or, Book My Show is just whatever, right? So they start to think that they just have to do the engineering right and everything will work, right? They have to focus on the scale and the UI, and then everything will work. And everything will not work unless you start to think, what will happen when I start collecting enough data? How would my product look then? And that's why, we don't have to build all the 4 layers completely, but have a version 1 of each done well. And then you can add more metrics. You can add more complexity to these models and more complexity to these models. But you have to always think, it's okay to put a rule-based system first or a, simple system first, but have all the systems in place and later on evolve all of them. Instead of saying, let me first finish this signal to state and then only I'll go to next. No, we don't perfect a tire first and then perfect an engine, right? We start building a basic car, then the next important car, then the next car, then the next car. So we need to think breadth first and then evolve our products. All the pieces that are, behind needs to go up. But think holistically and build one at a time. That's the general advice I give. Yeah.
Another question is,
Yes.
first thing comes into mind when booking the cab is that the safety and security of the customer. So how the AI or ML is going to concentrate on this from the cab provider perspective as well as the customer's perspective?
Yeah, very good question. So, all these companies are very worried about all the security and safety issues. And Ola has taken it as a mission now that, we want to make the whole thing safe. So safety, like anything else, is a multi-pronged approach, right? Many layers have to be done right. So, we have to verify the drivers, make sure, there's police verification, Aadhaar card and all that. So onboarding stage, what do you do? Then we have, all these things in the app itself. Then the customer can say SOS and things like that. During a ride, the customer can tell that something is wrong. And we have people called Ola marshals who are all over the city. They'll come quickly and, take care of you, right? So there are these things. So some things have to be done at the process level, right? Then we are doing things like authenticate the driver before he starts the car. So unless the driver speaks something or we do retina or face detection and something, the car won't even start or he cannot start the trip. It's not just the OTP is right, because if the person who signed up to drive that cab is not the person who is actually driving the cab, there's a big security issue, right? So you can do all your Aadhaar verification on the wrong guy, and the other guy is actually driving the car, right? So before every ride, we are trying to build systems which will authenticate the driver in multiple ways. It could be, thumbprint and this and that. And the fourth thing we are doing is, anytime a driver deviates from the prescribed route, right, we get an alert. So because Ola and Uber are now able to monitor every car, anywhere they are, in whatever state they are, right, with the customer, without a customer, we are able to detect whether it is normal for a ride to go from here, which is supposed to go from here to here, to take this left turn. Is it normal or not? And how do we know it is normal? Because other cabs have done the same thing, so this is normal. But if no cab has done this, then it is abnormal. So this whole thing about fraud detection, outlier detection, and all these technologies are used on the on-ride kind of stuff, right? So what I'm trying to say is it's a multi-pronged approach. There is part of it which is AI and ML. There's part of it which is process. But together, we're trying to make sure the security goes up quite a bit. Yeah? Great question.
Okay.
That's a good Ola question.
Yeah.
Yeah, it's a very, very big question. School buses, they have a problem. All kinds of such places, right? Truck drivers, security issue. Guys who deliver your food, big security issue. They can add anything in your food, right? Who knows? So packaging has to be done in such a way, whatever it is, right? So, yeah.
Oh, can I continue?
Yes.
Okay. So the multi-layer, diagram you shows, right? Like,
Yeah.
Signal to state,
Right,
and
right.
then state to actions, and all of this, right? So this is just I'm just curious to know. From there, even in the signal, you have multiple boxes, right?
Yes.
So now it's a one-to-one mapping from your state boxes to your signal to the state, and we are applying a single algorithm over there, or it's a mix of algorithms.
Mix of algorithms. So it's almost like a zoo of algorithms. So for example, think about, I'll give you an example in the security scenario, right? Imagine that the ride is going on. We have an audio sensor in the car, and the driver and the customer are talking loudly and arguing about something. So that is one signal, right? Now imagine if the car, the GPS and the way the car is being driven, right? The telematics of the car is another signal which tells me that the car is not behaving properly. Now there is altercation in the voice inside the car, and the driving of the car is erratic. Together, it's a overall state of the system, which is something is wrong, right? So the idea is, the more types of sensors you can collect, audio, video, thumbprint, retina, whatever, right, for any given application, the better the state you will be able to build, the more confident state you will be able to build, right? So like we saw, it's not about the visual sensor. We need sensors in infrared and all that. The more sensors you have, the better the state of the system you will understand, right? It's not just about the modeling techniques. It's also about the sensing, what you sense, right? And if you go to a medical checkup today, they'll give you this 200-page list of things you can sense on a human body, right? Just imagine sensing on human body. And then they can come up with a state which can be as simple as what is your physical health, psychological health, your sleep cycle, whatever, your cardiac health. These are your state. Imagine I combine all that data into those 5 numbers. That is your state. In the banking world, all the transactions you see, they can be converted into what is your willingness to pay, what is your ability to pay, what is the capacity to take more loan. So these are like 5-6 numbers that summarize all of your transactions. So this idea of signal to state is an art, really. How do you create better states from more signals and things like that?